This is 5.3/5.6, some applications of the definite integral. If you did not watch part 1 and part 2, please go back and do so. This section is super long. I'm going to make an assumption here that we're going to have 4 parts. So let's go ahead into part C, or objective C, which is average value of a continuous function, the mean value theorem for integrals. So if you see mean value, you know you're going to be doing something with average. So let's read this little example here. Imagine that a function f of x represents the upper boundary of water being sloshed around in a bucket whose sides are bounded by x equals a and x equals b. We know that the area under this curve is given by the integration from a to b of f of x dx. If you set the bucket down, the water will set it to a constant flat height, which is the average height, which is bar y. The area of the settled water can be found by multiplying the width of the bucket by the constant height of the water. So area equals width, which is b minus a, that's how wide the bucket is, times the height, which is y bar. Okay, so assuming that no water is lost in the sloshing, then the rectangular area of the settled water would have to be equal to the area of the water that is being sloshed. So therefore, b minus a, which is the width, times the height, which is y bar, is equal to the integration from a to b of the function at x dx. If we want to find the height of the settled water, which we think as the average value, then we can isolate y bar by taking and dividing everything by b minus a. So that's how I got the integration of a to b f of x dx over b minus a. Or we can say 1 over b minus a, the integration from a to b of f of x dx. So here's the formula. The average value of a continuous function, if f of x is continuous on a to b, then the average value of f of x on a to b is given by the function's average is equal to y bar, which is equivalent to 1 over b minus a. Remember, b is your upper limit, a is your lower limit, integration from a to b, f of x dx. So now let's go through and look at example number 4. Find the average value of the function on the closed interval. So first things first, I'm looking at that sine function, and when we did this before, we drew this up, and here it is. So here's pi over 2, here's pi. We get this gorgeous, first part of the sine function, right? So we're finding the total area. Sorry, I'm looking at the wrong one. We're looking for the average value of the function. So remember that average, or y bar, is equivalent to 1 over b minus a, integration from a to b, f of x dx. Okay, so remember that the upper limit is going to be b, which is pi, and the lower limit is 0. So when I put all this together, I get y bar equals 1 over b is pi minus 0, and integration from 0 to pi of the function sine x dx. Okay, so y bar equals 1 over pi, integration from 0 to pi of sine x dx. So we've already done the integration of sine x dx, but just to remind you that when I integrate sine, I get negative cosine x. And if I take that on the values from 0 to pi, I guess just for giggles, let's do this. So guys, what does this look like? Before I go any further, remember that your constant that's hanging out the integration is 1 over pi. So now if I take 1 over pi and multiply it by cosine, I get negative 1 over pi cosine x. Now go ahead and plug in the values. So let's do f at b, where x is pi. So I get negative 1 over pi cosine at pi. Okay, so this becomes negative 1 over pi cosine at pi is negative 1. So this becomes 1 over pi. So that's f at b. F at a, remember x is 0. So negative 1 over pi, cosine times 0. Cosine at 0, it's not times 0, it's cosine at 0. So cosine at 0 is 1. So this is negative 1 over pi. Now remember, I have to take f at b minus f at a. So I get 1 over pi minus 1 over pi, negative. So this becomes 2 over pi. And if you plug that into the calculator, so 2 divided by pi, I get 0.64, and this is y bar. So this is the average value of the function. So let's try b together. So we have the cube root of x plus 1 on the interval from negative 2 to 0. When I look at this, I know it's telling me to find the average. So y bar equals 1 over b minus a, integration from a to b of the function dx. So if I look at this guy, I can rewrite this as y bar equals 1 over, remember the upper limit is 0, so b, 0 minus negative 2, and then I'm integrating from 0, or excuse me, from negative 2 to 0, and the function is x plus 1 to the 1/3 power dx. So I know I have to use substitution on this because I cannot do this. There is no rule that matches up with x plus 1 to the 1/3 power. So I'm going to use substitution. I'm going to let u equal x plus 1. My leftover is dx. So du equals 1 dx. So I'm in good shape. So that checks out. That's good. But I have to take care of the upper and lower limits. So the upper limit, remember, was 0. So I'm going to plug that into the u formula, which is u equals x plus 1. So u equals 1. This is my new upper limit. So I'm going to go ahead and put a highlighter on that. And then I'm going to look at the lower one. So I'm going to let x equal negative 2 and plug it into u. So u equals negative 2 plus 1, which is negative 1. That's my new lower limit. Okay, now that I've taken care of that, I need to write up my function in terms of u. Okay, so don't forget that I have 1 over 0 minus negative 2. So I have 1/2, and I'm integrating from the new upper was 1, and the new lower was negative 1. And I have u instead of x plus 1 to the 1/3 power du. Okay? So now I have to integrate this. So it's 1/2 times, this is going to be 1/3 plus 1 over 1/3 plus 1. Okay, all right, so 1/2. If I take 1/3 plus 1, I get 4/3, and if you reciprocate that, you get 3/4, and u to the 4/3. So this becomes 3 over 8 u to the 4/3 power. And now I'm going to take that interval from negative 1 to 1. Okay, now evaluate. So I need f at b. Remember that u is equal to 1. So I'm going to plug this into this formula. 3/8 u is 1 to the 4/3 power. This equals 3/8. Done. F at a. I don't know why I'm not using my eraser. Let's just do that really quick. Okay, F at A. So we do 3/8 times -1 to the 4/3 power. If I take the cube root of -1, I get -1. But then if I take that to the 4th power, it becomes a +1. So this is also 3/8. So let's plug this in. F at B minus F at A. So 3/8 minus 3/8 equals 0. So the question is, that's kind of weird. So that is the average, right? The average there. So what that means is if you would go and graph that function out, you would find that half that function is below the x-axis and half of it is above the x-axis, and that is why it is 0. Okay. I'm going to stop the video and just make one more.